thank you for joining me. We want to talk today a little bit about Rolle's theorem. This is a theorem that ties the graph of a function to its derivative in a very special way. So first, the statement of the theorem. If we let f be a continuous function on a closed interval and differentiable on the corresponding open interval, and if we know that there are two places, two x values, for which, so here a and b, for which the y values are equal, then there is another x value in between a and b where the first derivative at that x value is 0. Now, why is that important? Remember that the first derivative is the slope of the tangent line to the curve. So what we're actually saying is if we can find a place where we have two x values that give us the same y value, we know that at some point there was a place in the graph where there was a horizontal tangent line. So here, for instance, if x is at 2, this f of negative 2 equals 8. And here, if they're about the same thing, we have f of 2 equals 8. So in this case, my negative 2 would be my a, and my 2 would be my b. Since these two are kind of equal, they're equal vertically, then in the graph is continuous. If the graph is decreasing, it has to come back up at some point to get back to that y value. It's the same thing if the graph were increasing. If the graph were increasing, in order to get back down to the y value, there has to be a turning point in the graph, so a maximum or a minimum. And we have seen that those places are the places where our first derivative is equal to 0. So for instance, the theorem says that there is one. So here is a place where there is a horizontal tangent line where the first derivative is equal to 0. It's a turning point in the graph. Our theorem guarantees 1, but actually in this picture we have 3. We have recently talked about Rolle's theorem, and now we need to talk about the mean value theorem, which is actually a generalization of Rolle's theorem, or as we will see, Rolle's theorem is a special case of the mean value theorem. So let's look at the statement of the theorem. The theorem says, let f be continuous on a closed interval and differentiable on the corresponding open interval. You'll remember that that was actually the first statement in Rolle's theorem as well. The theorem guarantees us that then there is a c in the open interval with this property, where the first derivative evaluated at c is equal to the difference between the y value of the endpoints and the change in the x values is what you're dividing by. You've seen some of these quantities before, so this should be kind of familiar. This right here, do you recall what this quotient represents? It's the slope of secant lines. So for instance, if this point right here were a f of a, and this point right here were b f of b, then the right-hand side of this equation represents the slope of this red line, the line that connects those 2 points. It's the slope of a secant line to the curve. What the theorem is guaranteeing us is that there is another spot in the interval between a and b, another x value, where the first derivative is actually equal to c. You'll recall that the first derivative is the slope of the tangent line to the curve. So this is a very important theorem because it's telling us that we're here, this is the slope of a secant line to the curve. And if the function is continuous and differentiable within that region, there must be a point where the slope of the tangent line to the curve is the same thing as the slope of the secant line to the curve. So for instance, right about here, you'll notice if I draw a tangent line to the curve, I get two lines that are parallel, so they have the same slope. We can additionally see that if we make the further restriction that f of b must equal f of a, If you'll recall, this was the additional hypothesis of Rolle's theorem that is not in the mean value theorem. But if we make that hypothesis, you'll notice that we get f prime at c equals f of b minus, we can substitute, since f of a is equal to f of b, we can substitute, which is equal to 0. Therefore, if we take the mean value theorem, we get Rolle's theorem as a special case of it where the endpoints are equal. Thank you for joining me, and remember, if you're not having fun, you're not doing it right.